Good day, everyone. You're welcome to our new topic today, taken from our hidden fact in new SSCE Maths, page 81. Indices involving quadratic equations. Let's take our first example. Solve the equation 3 raised to the power x squared equals to 27 raised to the power x over 9. The options are given as A minus 1, 2, B 1, 2, C 1, minus 2, D minus 1, minus 2, E 0, 3. Solution. Let's present our problem properly. 3 raised to the power x squared is equals to 27 raised to the power x over 9. Let us express the right hand side in 3 and its powers. That will give us 3 raised to the power x squared equals to 3 raised to the power 3x all over 3 squared. Applying the law of indices, 3 raised to the power x squared will be equals to 3 raised to the power 3x minus 2. What we have just done, we brought the numerator and the powers was subtracted based on the law of indices. Same base have been achieved. Next, we equate powers. That will give us x squared will be equals to 3x minus 2. Rearranging it properly, we have a quadratic equation as x squared minus 3x plus 2 equals to 0. Factorizing, we have x squared minus 2x minus s plus 2 equals to 0. If you have problem with our factorizing method here, please go to our quadratic equation, how to factorize. You will learn it better there. Now we simplify further. Factor out x, introduce bracket. There we have x minus 2, bracket close, minus 1. Then you open up bracket, x minus 2, bracket close is equals to 0. We proceed further. Factor out x minus 2, open and close bracket. Then you'll be left with x minus 1, open and close bracket is equals to 0. And what that implies is that x minus 2 is equals to 0, or x minus 1 is equals to 0. And that implies x is equals to 2 or 1. Another example. Solve bracket open x plus 1 when you close the bracket raised to power 2 is equals to 9 over 25. The options are given. A minus 2 over 5, 8 over 5. B 2 over 5, minus 8 over 5. C minus 2 over 5, minus 8 over 5. D minus 2 over 5, minus 5 over 8. E 2 over 5, 5 over 8. Solution. We represent our problem properly, and that would be bracket open x plus 1, bracket close raised to power 2 is equals to 9 over 25. We raise the right hand side to a number in the power of 2 to align with the left hand side. And that will give us, we open up the bracket, x plus 1, close the bracket raised to power 2 is equals to 3 square over 5 square. Next, we present it properly again, and that would be x plus 1, bracket open and close, raised to power 2 is equals to 3 over 5, bracket open and close, raised to power 2. It's indices. We have not done anything wrong. We can factor out power like that with ease. Since they are in the same power, we can equate the basis. We can equate our result will be x plus 1 is equals to plus or minus 3 over 5. Why are we doing this? Why we introduce plus or minus in the right hand side of the equation is both sides is squared. And when removing square, like taking square root of both sides, the value must give us plus or minus. That is, x is equals to minus 1 plus or minus 3 over 5. And when we solve further arithmetically, that will give us x equals to minus 2 over 5 or minus 8 over 5. Another example. Solve 2 raised to power 2y plus 2 minus 9, bracket open, 2 raised to power y, bracket close, is equals to minus 2. Solution. Applying law of indices, we have that 2 raised to power 2y plus 2, bracket open and close, minus 9 into bracket open 2 raised to power y, bracket close, is equals to minus 2 becomes 2 raised to power 2y times 2 raised to power 2 minus 9, bracket open, 2 raised to power y, bracket close, is equals to minus 2. And that is the same as 4, bracket open, 2y, bracket close, square, minus 9 into 2 raised to power y, bracket close, equals to minus 2. Next, we let 2 raised to power y to be equals to p. We can now restate our equation as 4p squared minus 9p is equals to minus 2. Rearranging, we have 4p squared minus 9p plus 2 is equals to 0. Next, factorizing, we now have 4p squared minus 8p minus p plus 2 is equals to 0. Now we can factor out 4p, and we now have 4p into bracket p minus 2, bracket close, minus 1, bracket open, p minus 2, bracket close, is equals to 2. Then we'll factor it out. 4p minus 1, once it's factored out, that will give us 4p minus 1, bracket open and close. Then we have p minus 2, bracket open and close, will be equals to 0. And the result will be 4p minus 1 is equals to 0, or p minus 2 is equals to 0. And that is to say 4p is equals to 1, or p is equals to 2. And that will give us p equals to 1 over 4, or p is equals to 2. Changing back to our original variables, we have p equals to 1 over 4 implies 2 raised to power y is equals to 1 over 4. Or p equals to 2 implies 2 raised to power y is equals to 2. Rearrange it properly, we have that 2 raised to power y will be equals to 2 raised to power minus 2. Or 2 raised to power y will be equals to 2 raised to power 1. That is to say y is equals to minus 2, or y is equals to 1. Another example. Solve for x if 25 raised to power x plus 3, bracket open, 5 raised to power x, bracket close, is equals to 4. The options are given. A, 1 or minus 4. B, 0. C, 1. D, minus 4 or 0. Solution. Expressing the terms in the left hand side to the smallest base, that is 5 raised to power x. We now have 5 square, bracket open close, raised to power x plus 3 into bracket open 5 raised to power x, bracket close, is equals to 4. What we have just done is that from the problem, the 5 raised to power x give you secret of what to do. And so that is what we have just done to 25. Now, 5 square, when you open up the bracket, is the same thing as 5 square x, 5 2x, plus 3 into bracket open, 5 raised to power x is equals to 4. That is the same as 5 raised to power x, bracket open and close, then you introduce square outside the bracket, which is the same as 5 raised to power x, bracket open and close, square, plus 3 into bracket open 5x, bracket close, is equals to 4. Now we can represent our 5 raised to power s to be equals to p. Let 5 raised to power s be equals to p. P squared plus 3p will be equals to 4. Properly presented as p squared plus 3p minus 4 is equals to 0. Factorizing, p squared plus 4p minus p minus 4 is equals to 0. We factor out p, and that will be p, bracket open, p plus 4, bracket close, minus 1 to bracket open, p plus 4, bracket close, equals to 0. We now have open bracket, p plus 4, close bracket, then open bracket. We have factored it out. Then we have p minus 1, bracket open and close, will be equals to 0. P plus 4 will be equals to 0, or p minus 1 is equals to 0. That will give us p equals to minus 4 or 1. Now, changing back to our original variable, we have p equals to minus 4 implies 5 raised to power x is equals to minus 4. Or p equals to 1 implies 5 raised to power s equals to 1. That will imply 5 raised to power s is equals to 5 raised to power 0. While we are taking only this, the first case of p equals to minus 4 will not help us in this problem. And you recall in indices, any value 1 is the same thing as the base we have the raised to power 0. That is to say, x is equals to 0. Another example. Solve for x such that 2 raised to power bracket open 2x squared plus 15 plus 7. 2 raised to power bracket open 2x squared plus 15x plus 7 bracket close is equals to 1. The options are given. A, 1 comma 2. B, minus 1 comma minus 2. C, minus 7 comma minus 1 over 2. D, minus 2 comma 7. E, minus 7 comma 1 over 2. Solution. From indices rule, we have that 2 raised to power 2x squared plus 15x plus 7 bracket close equals to 1 is same as 2 raised to power 2x squared plus 15x plus 7 bracket close equals to 2 raised to power 0. As we all know that when we are dealing with indices, 1 is the same thing as that base raised to power 0. Now, since they are in the same base, we can equate powers. We now know that 2x squared plus 15x plus 7 is equals to 0. Factorizing the resultant quadratic equation, we now have 2x squared plus 14 plus x plus 7 is equals to 0. And that will give us 2x, factor out 2x, bracket open, x plus 7, bracket close, plus 1, bracket open, x plus 7, bracket close is equals to 0. Okay, factor out bracket open x plus 7, bracket close, into another bracket open 2x plus 1, bracket close equals to 0. That's same as x plus 7 is equals to 0, or 2x plus 1 is equals to 0. And that is to say x is equals to minus 7, or 2x is equals to minus 1. And that is to say x is equals to minus 7, or minus 1 over 2. We've come to the end of the examples under this subtopic. Next, we have some exercises. You can try your hand on the exercises. Answers are given at the answer section of the book, either the hard copy or the soft copy. Thank you.